Match strings from one numpy array to another. Hi, I am working with Python 3 and I've been facing this issue for a while now and I can't seem to figure this out. I have two numpy arrays containing strings. If you notice, the array_1 is actually an array containing 1 gram, 2 gram, 3 gram, 4 gram, 5 gram for the sentence Alice in a Wonderland. I purposefully have taken Wonderland as two words wonder and land. Now I have another numpy array that contains some locations and names. Now what I want to do is get all the elements in the array_1 that exist in array_2. If I take out an intersection using np.intersect 1d of the two arrays, I don't get any matches since Wonderland is two separate words in array_1 while in array_2 it's a single word. Is there any way to do this? I've tried solutions from Stack, this, but they don't seem to work with Python 3. Array_1 would at max have 60 to 100 items, while array_2 would at max have roughly 1 million items, but an average of 250,000 to 500,000 items. Edit. I've used a very naive approach since I wasn't able to find a solution up till now. I replaced white space from both arrays and then using the resultant boolean array, true, false, true, to filter on the original array. Below is the code. But I am not sure this is the way to go considering the number of elements in array_2.
Sorry to pose two answers, but after adding the locality-sensitive hashing technique above, I realized you could exploit the class separation in your data, query vectors and potential matching vectors, by using a Bloom filter. A Bloom filter is a beautiful object that lets you pass in some objects, then query to see whether a given object has been added to the Bloom filter. Here's an awesome visual demo of a Bloom filter. In your case we can add each member of array_2 to the Bloom filter, then query each member of array_1 to see whether it's in the Bloom filter. Using pip install Bloom filter. Result: Wonderland. Depending on your requirements, this could be a very efficient, and highly scalable, solution.
Min hashing could definitely be used here. Here's the very general idea behind min hashing. For each object in a list, hash the object multiple times, and update an object that keeps track of the hashes computed for each list member. Then examine the set of resulting hashes, and for each, find all objects for which that hash was computed. We just stored this data. The objects for which the same hash was computed will be very similar if the hashing function is chosen carefully. For a more detailed explanation of min hashing, see Chapter 3 of Mining Massive Datasets. Here's a sample Python 3 implementation using your data and datasketch, pip install datasketch, which computes the hashes. Results, array_1 member on left, array_2 match on right. The easiest way to tune for precision/recall here is by changing the threshold argument to min_hash. You can also try modifying the hashing technique itself. Here I used 3-character hashes when building the min_hash for each array, a technique Yale's Digital Humanities Lab found tremendously powerful at capturing text similarity. This URL.
If you want to see more, please consider subscribing.